With Phil completing the top of our router table as well as the fence, this router table is ready to be put to use in the shop. But if you remember, there's one feature we added to the table that'll make it even more versatile. Of course, there's a little more work to do. Now, the feature we added was we allowed the tabletop to tilt from a horizontal to a vertical position. Now that positions the router horizontally as well as the bit. And that opens up some great possibilities for additional work. Of course, you need a way to guide and support the workpiece. What that means is we're going to have to add a horizontal table assembly. Now it's a two-part assembly. It consists of the tabletop, but in order to allow it to adjust, there's a fixed back assembly here. Now the fixed back has a lift block and a bracket, which we'll get into later, but those house this crank and threaded rod, which allow you to adjust the table up and down accurately to position a workpiece. I'll start with the simplest part of the horizontal table system, and that's the part that attaches to the tabletop itself, the fixed back. There aren't that many parts. There's a table back, a couple of brackets, and the lift block that houses the threaded rod and the crank handle. Now the table back is nothing more than a couple layers of plywood. They're glued together and then cut to final length and final width. The brackets are just a couple pieces of plywood. And all I did with those after cutting them to final size was to knock off the back corner just to remove the sharp edge. And finally, the lift block. The lift block fits between the brackets. It's glued up from 4 layers of plywood, and after that was glued up, I cut it to final width. But I left it extra long. That's because I need to locate the brackets first and cut the lift to fit in between. Now locating the brackets is simple. I'm just going to cut a pair of dados in the table back to house them. That's a simple task over at the table saw. To make quick work of cutting the 2 dados, I've installed a dado blade in my table saw. Now I set it up so that the width of the dado blade matches the thickness of the brackets that have to fit the dado. That'll give me a good snug fit when I glue and screw it in place later. Now to locate the dados accurately, I need to make sure I pass it over the saw blade under control. I'm going to use my miter gauge for that, and I've installed a long auxiliary fence since the workpiece is fairly long. Now because I'm not making a through cut, that means I can use the rip fence as a stop to position the workpiece. All I need to do is butt the workpiece up against the rip fence and make sure that everything aligns with the edges of my layout lines. With the workpiece firmly against the auxiliary fence and butted against the rip fence, make a smooth, steady pass to cut the first dado. Then flip the workpiece around and repeat the process to cut the second dado. Dado blade at the table saw took quick work of creating the dados for these brackets, and you can see they fit pretty well. But I'm not ready to glue and screw them in place just yet. I need to take care of a little bit of work here on the fixed back, and that is drilling a series of holes. Now there's a pair of holes at each end. Now those holes will be used along with some studded knobs to secure the fixed back to the router table top. Then I need to drill a pair of holes starting from the back side. The first thing is a counter bore and then a through hole. Now the counter bore will accept a T-nut, and that'll be used along with another studded knob and the through hole to attach the adjustable table to the fixed back. To drill the shallow counter bore, I installed a large diameter Forstner bit in the drill press and adjusted the fence to position the bit directly over my layout mark. Then I adjusted the drill press stop to drill an 1/8 inch deep counter bore. After drilling the counter bore at one end, slide the workpiece along the fence and drill the second counter bore. With the counter bores complete, install a smaller diameter Forstner bit to drill the through holes. Be sure to clear away the waste as you drill to avoid clogging the bit. After completing one through hole, just like before, slide the workpiece down, center it over the counter bore, and drill the second through hole. You can use the same smaller diameter Forstner bit to drill the through holes at each end for mounting the fixed back. After drilling 2 holes at the original fence setting, you'll need to readjust the fence to drill the final 2 holes. It didn't take long to drill the through holes at the ends of the fixed back for mounting it to the router table. Of course, there were a couple other holes to drill, and that was for mounting the adjustable table. Those were through holes with counterbores on the back. And once the counterbores were complete, I was able to tap the T-nuts into place. But I still needed to drill a couple more holes, and those are for the brackets. They're just shank holes with some countersinks. That allowed me to glue and screw the brackets in place. Now that establishes the space in between, so that means I was able to take the lift block and cut it to final size so it had a nice snug fit in between. Now because I'm going to install the hand screw and the threaded rod later, that means I had to drill holes for mounting that. So I drilled a counterbore and a through hole and installed the same T-nut just like I did before. That means the lift block is ready to be screwed into place. I want to make sure I position it front to back correctly. So I created a couple spacer blocks of MDF at the table saw. I'll just slip those in here, press the lift block into place, and make sure it's flush along the top edge. I don't want it to slip around as I screw things in place. I'm just going to add a clamp across the brackets here. I'll be able to drive the screws in this end, then I'll flip a clamp around and drive the screws on the opposite side. The last part of the fixed table to install is the mechanism that allows you to fine-tune the height of the adjustable table. Now that's nothing more than a hand wheel and a threaded rod. Now after cutting the threaded rod to final length, I took some time with a file to create a flat at one end. The flat at one end will fit into the hand wheel, and I'll position it under the set screw here on the handle. Just take my Allen wrench and lock it securely to the hand wheel. All that's left at this point is to thread it into the T-nut in the lift block. That completes the fixed back. Now I'm going to temporarily attach it to the router table before I begin work on the adjustable table. To do that, I'll just use a pair of washers and some studded knobs. With the fixed back secured to the router tabletop, we got a rock-solid support for adding the adjustable table. And the threaded rod and hand wheel means we can make quick and easy height adjustments. That means we're ready to start building the adjustable table. Now, there's a lot of components to that, but it all starts with a solid tabletop with 2 layers of plywood, and to create a durable surface, there's some laminate on top, just like the router table itself, and a combination track for adding accessories. Before working on the tabletop itself, the key to attaching it to the fixed back is the structure that's underneath. Now that structure consists of two assemblies. Each one of them is U-shaped, consisting of a pair of braces along with a plate at the back. Now there's a slot here in the plate, and you use that along with a studded knob and washer to fix the adjustable table in place on the fixed back. Once you've adjusted the height, you lock it in place. Now this assembly is pretty important to making a solid structure, so we wanted to make a connection here between the brace and the plate that was solid. And to do that, we're using a tongue and dado joint. And that's an easy joint to cut over at the table saw. After cutting each of the braces to final width and final length, I took one extra step, and that was to knock off this outside corner to remove the sharp edge and provide some clearance for any time you're adjusting the table. The next step is to work on the joinery. Now we're cutting a tongue and dado joint. The first part of that joint to cut is the dados on the inside face of each of the braces. Now it's a 1/4 inch wide dado, it's 1/4 inch deep, so I've set up my dado blade to match the 1/4 inch width, as well as adjusted the height for a 1/4 inch deep cut. But the key to all this is positioning the rip fence. What we need to make sure of is that once everything is assembled and the plate slips into the dado, that the back face of the plate and the back edge of the brace are perfectly flush. Now instead of measuring for that dado location, I'm simply going to use the plate. I'll set it against the rip fence, adjust the rip fence so that the outside face of the plate and the outside face of the dado blade match. To control the workpiece and keep your hands safely away from the blade, use a backer board and a push pad as you make the cut. The backer board will also prevent chip out on the workpiece. When you make the cut in the second brace, keep in mind that it's a mirror image, so adjust the workpiece as you make the second cut. After taking care of the two dados in each of the braces that creates the mirror image, I'm ready to work on the next part of the tongue and dado joint, and that's to cut a mating tongue at each end of both of the plates. Now that tongue needs to fit the dado. The nice thing about this joint is I can use the same dado blade, but I need to make two changes. One is to adjust the height of the dado blade, and that'll establish the thickness of the tongue. But I also need to work on the length. Because I'm going to have my dado blade right up against the fence, I've added an auxiliary fence to my rip fence and adjusted it to create a tongue of the proper length. Now you want to make sure you do a few test cuts to get the fit just right. Just like before, to prevent chip out and control the workpiece, use a backer board and a push block as you make the cut. Simply flip the workpiece around and repeat the process to cut the tongue at the opposite end. Only took a few test cuts to dial in the size of the tongue so it slips right into the dado. Now I'm not ready to glue up this assembly just yet. There's one thing to take care of on the plate, and that's to cut a slot in the back that allows you to lock the adjustable table to the fixed back. Now I'll take care of that slot over at the drill press. One of the simplest ways to create slots is here at the drill press. And it's just a matter of taking a circle template and using that to draw out the ends of the slots here on each of the back plates. Now for reference, I've just connected those with lines, and the circle template is sized to match the width of the slot that I'm looking for. Now to remove the bulk of the waste, I'm going to use a Forstner bit. Position the fence so that the center line of the slot is directly under the Forstner bit. After drilling a hole at one end of the slot, slide the workpiece down the fence and drill a hole at the opposite end. Then make a series of passes to remove the bulk of the waste. The drill press took care of removing most of the waste for the slots here, but there was a little more work to do. Now I started by taking a chisel and using that to knock off the corners created by the Forstner bit. Of course, that left things just a little rough, so I followed that up with a piece of scrap with some sandpaper on it and used that to smooth out the sides along each of the slots. Now that takes care of completing the plate, which means it's ready for glue up. So I'm going to add some glue to my cup here, and then add a little bit to each of the dados. Now I'll take my glue brush and I'll just spread that in the dado here itself. The other half of the joint is the tongue that's on the plate. I'll just add some more glue along each of the tongues. And along the one on the opposite side. Now I'm ready to assemble the joint. Add one brace in place. Add the other. One thing I want to make sure of is that the tops of the braces are flush with the top of the plate. Then I can add the clamps. I'll only be clamping along the back edge. So it's only going to take a couple clamps. As you tighten things up, there's a couple things you want to keep in mind. One is it's open here at the front, so that's going to make sure by adding a square in here, you can see I'm a little bit off, so I just need to readjust my clamps. Bring that back into square and release a little pressure. Now that we have a square assembly there, there's one other check I want to make. Get rid of this glue here. I want to take a rule along the back edge here, and since this dimension is fixed, I need to make sure it matches the dimension here at the front. Now that it's square and my dimensions match, this assembly can be set aside to dry. And I can start on the next assembly and then be ready to start working on the tables. While the glue was drying on the brace assemblies, I got a jump start on the next part of the adjustable table, and that's the tabletop itself. Now it shares a lot of similar features to the main tabletop. It's beefy, a couple layers of plywood, there's a combination track, and a nice laminate surface. But instead of an insert for the router, this time around there's a small notch along the back edge, provides clearance for when the router bit comes through, so you can adjust the tabletop up and down. Although this is a two-layer top, I'm not going to start by gluing both layers together first. The main reason is I need to attach the brace assemblies with screws through the top. If I installed it through both layers, when it came time to attach the plastic laminate, the screw heads might telegraph through. So instead, I'm going to attach the braces to the lower layer and then attach the top layer. It's a great way to do it because I can do all the work on the lower layer and then add the oversized top layer. Use the lower layer as a template to trim everything flush. Of course, I do have to complete a couple tasks on that lower layer. And that started with knocking off the outside corners and then using a sanding block to ease those sharp edges. And the notch at the back needs to be taken care of. I wanted some nice radiused corners here, so I started at the drill press by drilling out the two corners. Now I'll just remove the waste with my jigsaw. To establish the sides of the notch, cut to the waist side of each layout line. To remove the waste, make a cut with the grain at the back of the notch. The tricky part of installing the two brace supports is positioning them properly on this lower layer. The reason is there's a back piece here as well as the lift mechanism. So they need to be inset from the back edge, centered, and spaced properly. Now I'll use a couple spacers for that. One is 2 layers of plywood that matches the thickness of the fixed back. I'll position that along the back edge here of the layer so that it's flush along the back edges and clamp it into place. Add another one at the opposite end. Now that'll position the braces properly from the back edge, but I still need to position them side to side and account for the adjustment block. I'll set these in place, and then to position them properly, I'm going to use another spacer. Now I sized this spacer to match the lift block assembly, but I added 1/16 of an inch to the width. That'll give a little extra room so when you adjust it up and down, it isn't going to bind. I've drawn a center line on my lower layer and a center line on the spacer. I'll align those, hold it in place, and then slide the brace assemblies up against it to position them. Now I'm ready to mark my layout lines. Marking the layout lines for the location of the braces will tell me exactly where I need to locate my screw holes. I'll just trace around each one of the braces. Along with the back plate. And now when I remove these, I'll know exactly where the screw holes need to go. After drawing the initial layout lines, I removed the spacers as well as the assemblies so I could extend all my layout lines, know exactly where those assemblies were, allowed me to put some layout marks in for the screw hole locations for each of the braces. They're just centered on the brace, and there's another screw hole centered on the plate at the back. Now to glue and screw these in place, I'm going to use the spacers just like I did before. So I've installed my back spacer flush with the back edge, and now I'll take my glue and add glue in between all my layout lines. Now I can take one of my assemblies and I'll set that in place for now. I'll add my spacer, again making sure it's lined up with my center line, and then I'll repeat the process for the other assembly. I'll add the glue, set my spacer or my assembly in place. Now with everything there, I can start adding some clamps. Just want to make sure that as you apply the pressure, they don't slide out of position. Make sure everything is lined where it needs to be. That looks pretty good. Add my other clamp. Make sure that's tight against the back spacer. A little bit off there, so I'm just going to loosen these up. Slide this over. There we go. Tighten the clamps back down. Check everything on this assembly. Looks good, so I'll add the other clamps for that. There we go. And one more clamp. With everything clamped in place, just flip the assembly over. I've already taken care of drilling the countersinks on the opposite side, but there's one thing I need to do, and that's drill pilot holes for the screws. Just do that for a couple. Then install the screw. I'll simply repeat that process for the brace, the plates at the back, the other assembly, and then I'll be ready to move on. With the brace support assemblies glued and screwed to the lower layer, I'm ready to attach the top layer. Now remember, this was oversized. We're going to flush trim it later. But remember, there's a notch that needs to be located in both layers. I already have it in the lower layer, but I don't want to flush trim all this away. So I took my assembly, set it on top of that upper layer, just positioned everything, make sure I had an even reveal all the way around. Then I used the existing notch to trace it onto that top layer. Now I can just remove this lower assembly, and I used a jigsaw to remove the bulk of the waste using those layout lines as a guide. That just leaves a small amount to flush trim along with the rest of the upper layer. At this point, I'm ready to start adding glue. I'll just add a large puddle here in the center. And I just like to use a plastic spreader to move that glue around. And just want to spread that around and get a nice even layer. Main thing is you want to make sure it's out near the edges, so don't worry if you have to add more glue. And now just continue spreading glue, making sure it's all the way out to the edges. I like to spread it right off the edge just to make sure it's all the way out. Pull a little bit more over to the edge here. Looks a little dry in the back here. Well, that looks pretty good. Now I'll add that assembly. And just like when I drew the notch for reference, I just want to make sure I have an even reveal so that it overlaps all the way around so there's something to trim flush. I'll just start adding clamps. I like to work from the center, work my way out. I'll just snug up the first clamp. That glue is going to make everything slide around. And once I have it in position, just slide things where they need to be. Keep adding clamps. Now that everything is snugged up here at the back, everything looks good all the way around. I'll just keep adding clamps and then set it aside to dry. I'm nearing completion on the adjustable table. So after removing the clamps, after the glue dried, on adding this upper layer to the lower layer, there were still a few steps that needed to be taken care of before I completed the adjustable table with the laminate surface. The first step was to use a handheld router and a flush trim bit to trim the upper layer flush. Be sure to start the router with the bearing off the edge of the tabletop. Bring the bearing in contact with the lower layer and begin trimming the upper layer flush, working your way counterclockwise around the top. Be sure to maintain a steady rate around the corners and the notch area to minimize any burning. As you go along the back edge, be sure to trim the notch flush with the lower layer as well. With the upper layer trimmed flush, you're ready to apply the plastic laminate. Here again, I use spray adhesive, applying it to an oversized piece of laminate. After setting that aside, you're ready to apply the adhesive to the upper surface of the tabletop. Once the adhesive dries, you're ready to bring the two pieces together. To make sure I apply the laminate in the correct spot, I added a set of spacers and then set the laminate in place. After making sure the laminate was positioned correctly, start by pressing the laminate down in the center. Then, working to one side, remove the spacers, pressing the laminate in place. Repeat the process on the other side by removing those spacers as you work your way out. To make sure you have firm contact with the adhesive, use a J-roller and roll out from the center to the edges of the laminate to get good contact. With the same handheld router and flush trim bit, trim the laminate flush with the upper layer completely around the tabletop. This tabletop is just about complete. There's one more task I need to take care of here at the table saw, and that's to cut a groove along the length of the tabletop. Now that groove is going to house a combination track. Now this combination track isn't any different than the one in the main tabletop. It allows you to use a miter gauge or install accessories like feather boards. Now to cut the groove, I've already installed the widest dado blade I could in my table saw, and I've adjusted the height to match the thickness of the combination track. Now I'll need to make a series of passes, so I've adjusted my rip fence to space it from the dado blade to position the first cut on the tabletop. With the back edge of the table against the rip fence, press the tabletop firmly against the saw table to obtain a consistent depth of cut. An outfeed table provides solid support for the heavy tabletop as you complete the pass. Readjust the rip fence to remove additional waste, repeating the process just like before. Finally, make a final adjustment to the rip fence to widen the groove to match the width of the combination track. It only takes a few screws to install the combination track in the groove in the top of the adjustable table. Just about completed it, but I took care of one small task before installing the combination track, and that was to add a small steel strip here on the bottom. Now it's just a mending plate you can pick up at any hardware store, and it's attached with a pair of screws. The real trick is locating the mending plate. Now it needs to be located so it's directly over the threaded rod and hand wheel that's used to adjust the tabletop up and down. Now it's easier to see how all this works by installing the adjustable table. I'm going to set that in place. If we look underneath here, you can see how the top of the rod rests against the mending plate. So the mending plate acts as a bearing surface, so you don't have to worry about the threaded rod digging into the plywood. Makes it easy to adjust up and down. Now, of course, once you have the table adjusted where you want it, you need to lock it securely in place. And that's taken care of with a pair of washers and studded knobs. Now, those studded knobs feed through the slots in the back of the plate on the adjustable table, and they thread into the T-nuts installed earlier in the fixed back. Well, that makes the adjustable table fixed and it's ready for routing.